Okay, so nice to meet you. And before I introduce myself, let's watch a movie. It's called Java 8 The Good Parts. And it's basically a list of the new changes in the JDK 8, with the biggest one being the lambda expressions and extension methods, and a lot of stuff in the JVM, for example, the Nashorn project, which is a new JavaScript implementation, and removal of the permanent generation, which is huge changes. And also, yeah, that's the permanent retirement and a bunch of internal changes. So there's a lot of stuff to talk about, and it would be really hard to cover it all in only one talk. And sadly, we were supposed to do this talk with Andrzej, but sadly he's not around. He felt sick, like really sick, not drunk sick, so sorry about that. And we'll only focus on the things I think are the good parts. Okay, so this is Andrzej. I'm working with him in eBay currently. That's what he did, but let's go to me. Okay, so I am one of the more active people which run the Polish Java user group, which is the Krakow Java user group. And also I founded many of these groups, which I hope you know. So the Scala user group, or Lambda Lounge Krakow, or even the Software Craftsmanship. I hope you know me, but if you don't, now you do. Okay. This is a disclaimer I had to put in because of eBay corporate stuff. So these are my opinions, and I don't mean to offend or do anything more good or bad about Oracle. And if you have any questions, feel free to ask them right away. Okay, so in one sentence, Java 8 is the biggest release since always. I don't think even adding generics to the language was such a big change as we now have, with so many things coming into it. But let's not believe myself, let's believe Twitter, because Twitter never lies. So some of the tweets I found were, Java 8 is the new Guava. Who knows Guava? Right, I mean, it's nearly impossible to write Java before 8 without Guava. The amount of utilities it had was just tremendous. And another one, the most exciting release in history, and I put that in, sadly I don't have a screenshot, but it was tweeted by a Ruby person. So if a Ruby person is excited about the Java release, it's kind of huge. Okay, another thing is, since Oracle took over, we were kind of scared that Oracle might be not really nice to the community, but in fact it was. And this is the first JDK which was developed entirely in the open. So all the development is done in public, all the mailing lists are in public, and there's a continuous effort to bring it all to the public, and we can work with it also. One of such efforts is Adopt OpenJDK, which basically means you get to meet with people like we did at GeekOn this year. Okay, so that's Steve Poole, and that's one of the core guys from the IBM JVM. And maybe you're thinking that OpenJDK is only an Oracle thing, but the open in it is a real open. So all JVM developers do contribute to something to the OpenJDK. So here with Steve, we were testing and fixing the datetime API, which is called 310, if you want to sound smart. So that's how it looked. And this is Richard Warburton. So you can meet up with smart people who are really into the JVM, can help you kind of test it and find bugs. And during this hackathon, we actually found bugs in datetime. It was in the not so popular calendar implementation. I mean, we all use Gregorian calendar, but there are like 3 or 4 different ones, and they actually had bugs. And we fixed them, so it's great that you can actually go out there and fix the JVM. So if you want to, you can fix, test, hack, and document the JVM, which is kind of cool. The only thing you need to do, go to this URL, attend one of our test fests or just hackathons, and join. If you want to do it on a smaller scale, you can adopt the JSR. So you can adopt datetime, or you can adopt Java caching, which really needs help of people because there's not enough Oracle and IBM developers to do everything. Okay, but let's finally get slowly into the code. So how do you check Java 8? You go to JDK 8 Java.net and download it. It's currently a normal distributable, like you would expect. It's not only dev builds, so you can try it out. And it's supported by all major IDEs, including Eclipse, IntelliJ, and NetBeans. And they even, I'm saying they, but I mean IntelliJ, even understand that you can replace now things with lambdas. And it will be highlighted, and you can just change your code to use lambdas whenever possible. But there is one problem about this. So let's say you're using your laptop for work stuff, or also you have your own projects. It's not that easy to just replace it with JDK8 because things might still break. Well, they shouldn't, but they might. So there is a nice project called JEnv, which is basically, if you know Ruby, RVM, selecting different versions at kind of console level. That's the same thing, but for Java. So here in my console, I can do JEnv versions, and here I have a list of all the JDKs that I have installed. And it's easy enough to select a JVM to use in a local directory. So here I am in the TMP directory, and set the local JVM to 1.730. And then if you check versions, it's going to be highlighted, and here it says set by a file in TMP. So if you have multiple projects and one of them requires JDK8, you want to play with lambdas, that's the way to go. And also in Maven it supports everything you need, so you can just set the compile target to 1.8. So the two things I'm going to talk about, the good things, are the long-awaited time API, like I said, 3.10 if you want to sound smart, and all the JVM people call it this way. And then we'll go into lambdas. Okay, so that's how it looks like. And if you've ever seen Joda time, it's pretty much the same thing, because the same guy did it. So it's no coincidence that it looks very similar. And another nice thing was, when he was designing the new APIs, he actually sent out polls to ask people, do you like this style of API or this style of API? So it also had a bit of community involvement. So let's look at this code now. We have something that's called local time. And to understand what local time means, just imagine what local is. And local is time without a time zone. So it doesn't really make sense if you're an airline, but for easy use cases, you just have a console app. Local time is the easiest thing you can get. And it prints what you would expect. Now, the biggest pain point of the old date API was that it was, hands up, who knows? What's wrong with Java util date? Yeah, it was mutable. So if we were to modify a time in the old API, you would modify the old object itself. And this could lead to very nasty errors and bugs. So the new API is immutable. And if you do a plus minus 16, which by the way reads really nice, then it's going to not change the old instance and give back a new immutable instance, which is a huge win. And a question rises. Okay, we now have a new time API, but what do we do with all the SQL stuff in Hibernate? Will they support the new APIs? The answer is yes, because I mean it's a core thing. They are working together with the vendors of Hibernate or for whatever driver you need. And it's really easy to implement support for this new API. So it's going to be supported, so we can use it once JDK is out. Okay. Now let's go into the world of modifying it in a readable way. So we have local time now, and that's easy, right? You can always use minus days, plus days to easily represent something in the future or past, but you also have helper methods like add time to modify an existing instance. So here we just did a local date, and look at the API, it returns a local date, but once you use yesterday at time, it returns a local date time. So in the API, we know if it has a time or not. With date, you don't really know, right? With the old date implementation. Okay. Now let's go into the real world. And the real world has this funny little thing that's called time zones. And yeah, let's just read the code for now. So we can get time zones by the known strings that everybody knows and understands. And there is also a pool of constants for them. So you don't have to have magic strings in your code, but for readability's sake, I've used this one. And you can always construct it just like that using the off factory method. And the nicer thing is here the duration between zoned date times. So again, notice that we are using a zoned date time, so we know just by the type that it has a time zone. So we will not run into this problem, does it have a time zone? Is it in America? Is it in my local time? So you have it in the type, and you won't as easily forget it as you could in the old APIs. And what duration is really awesome at, it understands time zones. So it will actually give you, if you have a flight from one part of the world to another one, it can actually give you the amount of hours you would be in the plane. Or the difference just by numbers. You can use different duration between versions for that. Okay, and here the toString. Who knows this funny little string? So it's PT11H30M. It turns out that's a standard. So it's ISO by default, not like the old APIs. So it's easy to pass in and out every other date time that you might encounter in the real world, because pretty much everyone uses ISO. And in the past, you would very often see this magic string, right? So no more, because it's ISO by default. And we also have constants in the JDK now for it, and it will print just what you would expect. And again, here we have an ISO date, an ISO date time. So it's really readable and does what you would expect. And it does even more. It does not only print what you would expect, but it blows up when you would expect it to. So in the new APIs, if you have an ISO date time, but use it on a local date, notice not local date time, so we are missing the time, so this doesn't really make sense. So it will actually blow up. Sadly not at compile time, but it's still a huge improvement over the old APIs. And I need a quick sip of water. Sorry. Okay. Okay. So if you want to learn more how to use the new APIs, there's a very good tutorial on this site. I'll share the link and the blog the slides on my Twitter account, so no need to write it down right now. So let's go further. One of the fewer, maybe funnier things in the Java kind of ecosystem was always the I/O, right? How many lines does it take to read lines from a file? I couldn't really fit it in my hands even if I tried to. So finally, after so many years, we are able to get files from a path. Finally. And like you notice here, we are using paths. So the new paths API from Java 7 comes over to the new JDK 8 APIs. So it's really nice and kind of fits into the old ecosystem. It's not a full rewrite. And we get the new things like listing of files and doing a nice I always call it a tree walk, not sure why. It actually is. So we can walk a tree directory, and you can decide if it should go inside each directory or not. And we finally can do that without external libraries. And the best thing here, you can use those. So here you get a stream, and you can use this as a stream, which we'll cover in a second. So it's a new API. It's not really a new collections API, but it's kind of similar to it, and allows us to use lambdas with collections very nicely. So all the new APIs, and also all the old APIs, have been retrofitted and kind of modified to work with the new lambda system. An example would be maps, which have gotten a few nice methods. Let's just look at the methods here. So you can either compute something, which takes a key, and a by function from a key to a value, which basically means if I have this key in my map, pass in the value, and I return another one. Or you can compute if absent, which does the same thing, but it only does the compute if the key was absent. So you get the key in, and can compute and put it into the map in one operation, and that's atomic. You no longer need to synchronize before getting something out of the map, doing the computation, and then putting it back, which I've done many times, so I find this very convenient. And you can also do a compute if present, which would be replacing a value in the map, which still is one atomic operation. But I started talking about lambdas, and this doesn't really have them, but it can. Okay, so if you have a map, you can use all of these APIs, like you've seen here, which would take a by function or a function from key to value, you can use them with the new APIs, which is the lambda syntax here, which we'll cover in a few seconds. So, a few nice additions to the collections API, and list and other collections also gotten a little bit smarter. You can also get to default, which is a nice pattern coming from the optional pattern, but instead of getting a null back, you can get some default value back, maybe a null object, and a few more. So this is a first example of using the streams API, though it's a bit implicit here. So we can do an arrays parallel set all, and here we give an array which has a length of 8, and here we put in an anonymous function which uses this atomic integer to increment it by 1 each time. Okay, the thing is, it's parallel, and it uses the streams API, so like you see here, the output wouldn't be sequential. And underneath, it's using the fork join framework, which people maybe know from Java 7. Fork join? Oh, not so much. So fork join is a really nice method to parallelize computation. And the really awesome thing about it is it's way smarter than we could have implemented it, because it's optimized on C level, and it's actually looking, okay, here's my data, here's my CPU, which is running this thread, and it tries to localize the data as near to the core that is running the thread. We couldn't really do this from Java level, because we don't really know which core something is running on. So really smart stuff, and really fast, but it also pays a price to start up these thread pools, right? So it's nice, but use it for large data sets. Don't use parallel streams if you have 100 elements, right? Okay. Another example of lambdas, but lambdas. Who has been waiting for lambdas for many years? I mean, we all have, so finally. And yes, it is pretty much inspired by Scala, Groovy, and Lisps, and all the languages since probably 70 years or so. I mean, since when was lambda calculus around? It was pretty much the beginning of time when you think as modern programming languages, kind of in the sense of it. So, what is the syntax of them? It's not hard, and people in the US started calling it the lambda burger. I mean, if you get these huge American burgers, they have this stick inside of it. So this is the burger and this is the stick. Well, weird name, but it's kind of cute. Okay, what can you do with a lambda? Or maybe let's first call a lambda by its proper name, so it's an anonymous function. It's not the same as an anonymous inner class, though you could implement them as if they were anonymous inner classes with one method, and you'll see it looks similar, but the implementation is actually, for one thing, it doesn't use anonymous classes. For the second one, it doesn't allocate objects per lambda. If you look at the lambda, you might think, I'll generate a class, and I'll allocate this object, and I'll call it later on. This is not what is happening. In reality, when the compiler sees such a lambda that takes a thing, it generates a method inside the class that takes a thing as the first parameter. And also, if you would use anything from the outer scope inside here, this method would take it inside as parameters. So it's not the same as an anonymous in a class, it doesn't cost as much, and it's actually faster. So it's big JVM changes for a very small thing. Let's look again at the many ways to write a lambda. So that's the easiest, and you still have to write the type here, because the compiler doesn't yet have any context what this type should be, but this is another way. So you can have multiple parameters, which is a function that takes 2 and returns nothing. But this is the first time in Java land that we have compiler type inference. Woohoo! Okay, many languages had this for many years, but Java is now finally catching up. And let's say you have a getNum. This is a functional interface. We'll talk about them soon. But imagine that this defines somehow a function from an int to int. So the compiler can look at the left-hand side and see, so I need an int-to-int function. It looks at the right-hand side. Okay, that's an int as result type. One thing is valid. And what can this t be? No one does anything with it, so I slap an int in front of it. So it will actually infer the type of t to be an int, because that's the only thing it ever could be. So in terms of how we can write lambdas, we can write them a bit smaller. So you can skip these curly braces, or you can also skip these round braces, which is very nice when you have a method that takes a lambda. You don't want to have 4 parentheses inside this. It would be kind of cluttery. So it's pretty nice. But let's now talk a little bit about the types, which is my favorite topic. Okay, so does this look like a function to you? It kind of does. We've been doing functions like this for many years in Java, which are basically single method interfaces. So let's look at it. An adder interface is basically a function taking 2 integers and returning another one. Fair enough. So what happens here is the compiler looks at it and compares the signatures. Okay, it's an add method. Okay, so here I have a lambda that's from int and int returns an int. And also notice there's no return statement and no colon here, semicolon, which is nice. So the compiler looks at the signatures, compares these two. Okay, that's fine. And then it looks at the return type. It's actually here, again, inferred. It looks at what the return type would be and compares it with the method's signature. And if they match, this lambda can be transformed in this interface. And again, it does not create an instance of it. It only acts like it would. So you do not allocate each time you encounter this line. It's one code generation, and then it keeps reusing it. Okay, so like I said, int-to-int converted to the target type. The name for this entire process is called target typing, because a lambda by itself doesn't really carry a type by itself. So the problem here is that the JVM doesn't really have functional types, and adding them to the existing type hierarchy of the JVM would be an unbelievable pain, like I talked with some of the compiler guys. So we made a compromise. We retrofit the new kind of functional way in our known way. And the known way is interfaces with one method. And of course, like I said, we have compiler inference, so you can write it a bit shorter now. Sadly, you do have to put the parentheses around A and B in this case. Okay, types are inferred. That's easy. So what is a functional interface? A functional interface is just an interface, okay, just an interface, and this annotation that I've displayed here, so functional interface, is only a helper annotation. It doesn't magically make an interface a functional interface, but it helps you to notice as, hey, I expect this to be a function. And this works the same way as override would. So, you know, like override works, it tries to assert that you're doing the right thing, right? So if you have an override annotation and you don't override something, then it blows up at compile time. So here you do the same thing. If the compiler comes in and it tries to assert that I expect this to be a functional interface, and you have 2 methods inside, that's not really a function. A function has one signature, so this will blow up at compile time. And this is why we should be using the functional interface annotation if we expect it to be a function. Okay, which is nice. And there's a trick inside that, because we actually need more methods in interfaces now. And I'll explain in detail why, but first let's go into this example. So there's a new keyword, actually a new keyword location, which is called default methods. And the default method is what other languages may know as traits. So it's an interface with implementation. Okay, which carries the problem of, do we have multiple inheritance now in Java? We can implement more interfaces. Interfaces can now carry some behavior. Do we have multiple inheritance? Yes and no. So the answer is yes and no, because we do have multiple inheritance of behavior, which is methods, and no, because we do not have multiple inheritance of state. And to be honest, this is one thing Java 8 does better than Scala, and I think inheriting state is really dangerous. And if you look at the initialization order of things, it gets really messy, because sometimes things may have been null if you initialize state from many places. So it's actually a very good choice, and we can still avoid the diamond project, known from C++, by... Oh, that's the next example, sorry. So you can avoid the diamond project in a few seconds. For now, you can just implement many methods, many interfaces, and get many methods from them. So in here we have an adder and a divider, and these don't have to be functional interfaces, right? That's just one example. And you can implement both, and in here in the calc method, we are actually using divide and add, which came from these interfaces. So yes, it is multiple inheritance. We have mixed in methods. So you can actually say you mixed something in now. And yeah, these are the mixed ones. And now to the edge case. So the edge case is when you have two traits. I'll call them traits since I'm so used to it, sorry. You have two interfaces with default implementations, and they have the same signature. And now the problem arises when you extend both, because boom, the compiler is not sure which one you mean, and it blows up as soon as possible. So it blows up as soon as you write a class that brings in something that's weird. So in here, if you would call on an instance of thing, do it, we wouldn't know which one we mean. So it blows up right away. The way to resolve this ambiguity is to select by hand which one we meant. Okay? So there were a few proposals to make this a special syntax, like default do it A, but it would add again a layer of complexity to the compiler. So let's keep it simple. Use what we always used. So just overriding a method and selecting the right thing. So if you do this, the compiler will stop complaining. And if you really want to, you can still call the version from B. You just delegate to B in another method. Okay, but why do we actually need default? Okay, it doesn't really make sense until you think about collections. Because the collections API, which now has to use lambdas, and maybe has to get a new method, like here, the iterable interface has gotten a new method, and obviously you want to for each in the functional style on collections. But if the architects would add this method to the iterable interface and don't provide a default implementation, then all the collections implementations in the whole world, and there's a lot of them, would break because of a missing implementation. So the thing they did here is kind of save their skin by providing a very simple implementation. So now iterable has gotten new behavior, and this is it. And mostly, this is what you would do in most of the collections. You just iterate by doing a for each over it in the old syntax, right? And when you see here that the argument here is a consumer of t, think about it that you saw a lambda doesn't really have a type. We don't have a way to describe a lambda's type by something other than an interface. So we got now interfaces that do the most popular things, like function, which takes one thing and returns another one. And a consumer is a function that takes one thing and is void. Okay? So it basically allows you to supply a lambda into this. And obviously, many other APIs didn't really need to be retrofitted, because out of the box, how lambdas work, they work with old code. So when you have a Swing app and you add a listener and it only has one method, it out of the box is a functional interface. And IntelliJ would actually do this since a few years, saying you wrapping it up into a lambda-like syntax. But now, you can actually do it in Java 8, which is nice. So we don't have to change our existing code bases to use the new features. Another thing, yeah, functional programming, so let's do stuff with functions. So what you can do with functions is obviously combine them. That's kind of the reason to have functions, because you can have small snippets of functionality and then compose. It's even the same word, right? You can compose these functions. So here we have a function that duplicates something, and here is an add one function. And then we can compose or and then them. The only difference is which function we wrap with which function. So the compose is the math way, right? F or the G, you know it. So it's basically a crusade against boilerplate. And boilerplate being these anonymous classes we've been writing for so many years. But it's more. The more being streams. So I did say a little bit about them, that it's using fork join and it's super fancy, but let's look at some of the pain points we had in previous Java editions. The primary example would be transforming a list. So in Java, there wasn't really a nice way to transform a list from one set of values to another one. Right? You would allocate a new list, then iterate over the old one, adding each new element to the new list, and then returning the new list. So nobody was really doing that for I don't know how many years. People were using the convenience function coming from Guava, which was the transform. So the first argument being the input kind of list, the second argument being a function from an integer to the whatever we want to put out, in this case a string, and then we have a string method that's called apply, and it acts like a function. So yeah, you could use the Guava functions to do this transform again, but you can also do it with streams. So streams are the biggest addition to the collections API, which is not an addition to the collections API. And I keep contradicting myself today, but it's actually true. So when you look at it, it does act like collections, but it's not in the collections API, because there's this bridge method. So whenever you want to do these bulk operations, you have to call a .stream or .parallel stream, and then you enter this new API land. And this new API land has, for example, a map method. Why map and not transform? So that's a historical thing. All the functional programming languages since ever have called this operation a map. If you look at all the Lisps or the Haskells or whatever functional language you want to throw at me, it's always going to be map. Unless it's Ruby. Ruby is crazy. And it's not pure. So a map is in the sense we map a value to another value. So in here it's really easy. We take in the int and we toString it. Does it do the same thing? Yes and no. There'll be an example later on. So yes, I'm doing a comparison to Scala, and I think it's actually getting better because we now can lift methods. By lifting a method, I mean this crazy syntax, which looks a bit like C++. So yeah, C++ syntax, I would like the below one, but the convenience of having some method and then lift it into the function world, which is 10 minutes. Okay, that's fine. So you can lift a method into the functional world, and just over a stream of items, you can just lift the method and call it on each element. So we're cool now, okay? We have something like pointers to methods. It's kind of cool. So let's look at everything the new stream APIs give us. And it's not everything, sorry. It's just the most popular operations. And I don't really have to explain them, because filter, predicate, we've all filtered our list before, right? And the others are also pretty easy. Distincting one, sorting one, peeking at a few elements. That's kind of easy. The hidden tricky thing here is a map to int. Okay, because this is all working on objects. And we want to use this also for primitives. But primitives, you can't really expose them as something in a type parameter. You cannot do a function of int, small int, right? So sadly, in the APIs, this was exposed, and we have hard-coded functions from lowercase int to object, from lowercase double to whatever. So it's a bunch of generated classes for us, and sadly in the APIs we have to use them directly. So if you want to use ints and avoid boxing, you have to use map to int. Okay? The rest is easy to read up about. Another example of iterating inside, which is great because we can now parallelize it by only one change, making it a stream parallel. Fair enough. So like I said, this will use the frog join framework and do it faster. We hope so, at least. So always test first, and does it really do what you think it would, because parallel doesn't always mean faster. And another very important thing here, it's lazy. It's really lazy. I hope you know what I mean by lazy, but let's test it out. So, what would this code print? We have a collection 1, 2, 3, and we map it twice, and we print and return the same value. So this would print A1, for example. What would be the output? Yeah, someone knew. So the output is nothing. So the problem here is, well, it's a feature. So the feature is that it will not apply these functions unless we do a collector, so a terminating statement. The terminating statement can't be a collect to list, which says, yeah, I'll do all these things, and I want to get a list back. So there is a set of predefined collectors for us, and it actually, the interface is quite big. It's like 5 methods, but you can write your own also if you want to. So if we do the collect, this is what will be printed out. Okay? And notice, it's really lazy. So if you would expect 2 iterations in this example, that's not like what's happening, because it's actually 1 iteration. And you can see it by the order of the ones. It's A1, B1, so it actually applied this, and then it went on to the second iteration, right, to this element. So it actually does it in one iteration. It combines the functions and then applies them. So it's really smart and helps you to write performant code, which maybe would be too hard to write by hand with all the for loops, right? Now just a few things about the handles, which we already talked about, but kind of implicit. So when you lift a method, what is the type of it? And this is where the new interfaces come in, because we need some common interfaces for getters, setters, constructors. So in this case, there's a new interface in Java, I believe util function, I think so, versus supplier. So a supplier is pretty much a getter. Takes a nothing, returns an t. So if you're very weird, you can write a person get name, that's lowercase. Oh, actually no. So that's a new person. Oh, I didn't do the new person. But you can write an apply to some type and the lifted method handle, if you really want to. It would look like this. And then here you are using a function. So this function would be from person to string in this case. And there's a bunch of more of them. That's the most prominent ones. And the by predicates being taking in 2 parameters. So there's also a by function, taking in 2 things and returning another one. Okay. One problem here, 5 minutes? Okay. So the problem here is we cannot really cover all the functions. Well, Scala does, but only until 22 parameters. And the problem here is we cannot really do it in a generic way until we generate these function 4, meaning 4 input arguments interfaces. And it's kind of a hack. It's kind of ugly. That's how Scala does it. But Scala has always been hacking around its way underneath. And they wouldn't really want to pollute the JDK specification with function 4, function 5, function 6. So if you ever need to lift such a method, you'll have to write the type, the target type, by your own. So you can lift it, and if you want to read more about it, here are a few very good links. The best link here being Brian Good's blog, where he explains all the decisions why something was made like this, what they tried, what they didn't try, and what they can do in future. Or you can also try this small project where I've been playing around with lambdas. And that's it. And if you have questions, I think we have a minute or two.
Yeah, there's time for like one question.
Go ahead.
Okay, any questions? I believe there's no question at all.
Just grab me on the break then.
Okay.
Thank you.
Thank you very much for the presentation.